constant horizontal force F is applied to a block Y. Block Y is in contact with separate block X. The blocks remain in contact as they accelerate along a horizontal frictionless surface. Y has a greater mass than X. Air resistance is negligible, which statement is correct. To solve this problem, I'm going to consider the second Newton's law. Net force vector is equal to ma vector, and consider this vector equation in projection to get scalars, just numbers, in projection on horizontal x-axis. And let's consider what forces are there. There is a force that y exerts on x, and also there is a force that x exerts on y, and its action-reaction pair. These forces are equal but in opposite directions, and let it be some force, for example T to the right, and the force of the same magnitude to the left. Definitely there are weight, normal reaction for y, for x, but these are vertical vectors, and their components, or in projection on horizontal axis, it will be zero. It means that they don't affect on the motion in horizontal direction. And now let's consider the second Newton's law for y. And definitely there is acceleration to the right, and for the object y, what forces are applied to the object y? F to the right, so it's positive F, minus T is equal to mya. And the second Newton's law for the object x, T to the right, and it's the only horizontal force on x, is equal to mxa. Acceleration is the same, but masses are different. And now let's consider options. The force F is equal to the product of the mass of y and acceleration of y, and from this equation we can see that F is not just ma, it's there is additional plus t, so a is not correct. A is not correct. Let's consider C. The force that y exerts on x is less than the force that x exerts on y. It's not correct because these two forces are action-reaction pair. So these forces are equal and of the same magnitude but in opposite directions. So C is not correct. Let's consider D. The force that y exerts on x, it's actually T, is equal to F. We can see that T is not just F, and T is not F, so it's not correct. And let's consider B. The force that y exerts on x, it's about T, is less than F. From this, we can see that T is F minus my acceleration, which is equal to T, and we can see that T is less than F, because it's F minus something, so B is correct. And that's all for this question.